Hey everyone, and welcome back. Here we're going to explore task 4.8. Yes, we did skip 4.7. That's okay. 4.6, if you remember, had the Ferris wheel scenario, and we're back right in the Ferris wheel scenario. Before we dive back into that Ferris wheel scenario, though, let's explore the warm-up. Just as a reminder, I want you to make the best use of this video for yourself. Pause it at any point. Rewind it, fast forward it. If you haven't played around with the playback feature, definitely change the playback speed to be exactly what you need it to be. It's that little gear in the bottom corner. You can change the playback speed to 1.5. That'll make you go a little bit faster. 1.75 will make me sound a little bit like a chipmunk, but it'll make me talk faster. And anything slower will just make everything I do run a little bit slower. So make this video useful for you. And with that being said, let's do our warm-up. I'm going to read this out to you guys because I know sometimes it's easy to skip through the reading, and research shows that even up through the ages of college students, being read things out loud helps with your reading comprehension. So here we are, definition of cosine. We begin with a circle of radius r. That's what we're looking at right here, a circle with radius r, whose center is located at the origin on a rectangular coordinate grid. We represent an angle of rotation in standard position by placing its vertex at the origin. The initial ray oriented along the positive x-axis, and the terminal ray located theta degrees counterclockwise around the point of the origin when theta is positive, clockwise when theta is negative. So here we have our positive rotation of theta counterclockwise, or I like to think of it as just up. It literally is just going up in the positive direction. So let the ordered pair x, y represent the point when the terminal ray intersects the circle. So we're talking about this point right here. In this diagram, angle theta is between 0 and 90. Therefore, the terminal ray is in quadrant 1. A right angle has been drawn in quadrant 1, similar to the right angles we've drawn in the Ferris wheel task. So we're talking about this little right triangle right here. So based on this diagram, what is the cosine? Well, let's zoom in on this a little bit further and kind of explore it. If this is a right triangle, this would be our x-coordinate, this would be our y-coordinate. Cosine of this angle right in here would still be adjacent over hypotenuse. So if we're looking at this, it would be x over r. So knowing that our cosine is always directly connected to the x value, the rest of this warm-up just asks us to have a quick mental thought about this. Knowing that cosine is always attached to the x value of any coordinate, let's explore angles outside of the first quadrant. Can we name at least 5 angles where the cosine will be positive? And think about that right now. Where is the cosine going to be positive? Then let's kind of do a similar question, but just flip it. 5 angles where the cosine will be negative. I want you to list those out. And if you're not sure, if you have questions about them, this is a great question to bring up in the office hours. But you should have a pretty clear understanding of where our cosine's positive and where our cosine's negative, strictly based on the x value. If I kind of want to think about it in different terms, it's like asking where is our x value positive. So again, cosine can just be replaced with where is the x value positive. And here, where is the cosine, the x value negative? Hopefully that clarifies it for you. So expect to answer that question when we see you in the office hours. Let's dive into this task. So this task is revisiting our friend Carlos. If you guys haven't tuned in with the scenario in a while, let me remind you what's going on. Carlos and Clarita are celebrating something. Maybe it's a summer at the fair, and they are waiting in line to go on this Ferris wheel. Now, the first half of this module, the first half of the tasks we've done, are Carlos staring up at that Ferris wheel, super scared to get on it and wondering how high off the ground he's going to be at every single point. In my mind, I'm thinking he's planning his exit. Where can he safely jump off this Ferris wheel so he does not have to deal with the panic of riding this Ferris wheel anymore? But that's my own mind. By this point, though, he has conquered his fears. He has stepped onto that Ferris wheel. He is actually experiencing the ride all the way around, and he's not dying. He's just fine. But his brain is still thinking in terms of trigonometry instead of just enjoying a ride around the Ferris wheel. So now let's think like Carlos. He's riding this Ferris wheel at dead noon. That means the sun is directly overhead. It actually marks that for us, so I want to underline that. The sun is directly overhead. And he's scared, so he's just staring straight down, anticipating that time to get off the Ferris wheel. And he notices his shadow just goes back and forth, back and forth, back and forth. So if you imagine his shadow being cast on the ground, here is our ground underneath the Ferris wheel. His shadow starts over here, being cast directly down from the starting point of the Ferris wheel. And as he rotates around the Ferris wheel, his shadow moves this way until he rotates all the way to that opposite side, and then his shadow heads back until he rotates back around. And let's make a second trip around the Ferris wheel. He's going to keep rotating. His shadow is going to move back in this direction. Then he's going to keep rotating, and the shadow is going to move back in this direction. So he's just watching his shadow go back and forth and back and forth and back and forth on the ground. So, knowing Carlos's trigonometry-minded brain, he says, you know what? I want to know how far I am from the center of the wheel at any point. Just strictly horizontally, how far am I from the center of the wheel at any point? Same Ferris wheel, so all these details are the same. Radius of 25 feet, 30 feet off the ground, counterclockwise rotation every 20 seconds. But now we're describing Carlos's shadow. His shadow. So let's look at the Ferris wheel and let's break down his shadow. I'm going to start by going through the times because the times have not changed. They have not changed. If you remember from the last task, this is 0 seconds. A full rotation around the wheel is 20 seconds. So let's do a half rotation around the wheel, which is 10 seconds. A quarter rotation of the wheel would be 5 seconds, which means 3/4 of the wheel is 15 seconds. And then if I look at all of these regions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are kind of 10 spokes or 10 regions around the wheel. So 20 seconds divided by 10, each one of these sections is going to be a 2-second difference. So once again, B is 2 seconds, C is 4 seconds, D is 6 seconds, 8 seconds, and let's just label all the way around the wheel. But now we're not looking at height off the ground. We're saying we know this is the ground down here. And Carlos wants to know how far he is from the center of the wheel at any time. So we're going to call this 0 feet. And let's think, well, what's the farthest he's ever going to be away from the wheel? Or if you want to think about it of his shadow, what's the farthest his shadow is ever going to be from the center of the wheel? Well, that should just be the length of our radius, because that is the farthest he's going to be from the wheel. So remember, our radius is 25 feet, which means the farthest he'll ever be is right here, 25 feet away. But he's also going to be 25 feet on the opposite side But thinking about this down here like a number line where this is our positive infinity and this is our negative infinity, we would call this side negative 25 feet. So we can actually have negative values in this scenario of the Ferris wheel. So let's find position B by drawing a triangle and using what we decided in the warm-up. What we decided in the warm-up is that the cosine of some angle theta is this little piece, which we're going to call x, over the radius, which is 25. So let's find that value. We know what that theta is. Once again, it's a tenth of the wheel. A tenth of the wheel is 36 degrees. Whoops. Sorry, guys. Okay, a tenth of the wheel is 36 degrees. So we can now say the cosine of 36 equals x, our adjacent side, over 25, our hypotenuse. Multiply 25 to both sides, and now x is 25 cosine 36. So that would be our distance from the center of the wheel. (25) times the cosine. I'm going to plug that into a calculator now, of 36. By the way, if you're using a Google calculator, it's going to default to radians. Make sure you change it to degrees. That's going to be super important to be in degrees for this first part of the module. We'll eventually switch to radians, but make sure you're in degrees. So in degrees, that's going to be 20.2 feet. And I'm going to kind of like draw that down to show you that, yeah, that kind of makes sense right there. That is about 20 feet from the center instead of 25, which is the full length. So let's try the same thing for C. Position C, just like we did before, it's not just like cutting the distance in half or going closer by a factor of 2 or 1/2. It's changing the angle. So instead of the angle of 36 this time, we're going to use an angle of 72. We're marking out 2 of those chunks of the wheel, or 2 of those tenths of the full circle, which is 36 and 36 and 72. But it'll be the same thing. It'll still be 25 cosine instead of 36, 72. And once again, I'm going to put that into my calculator, remembering to put my calculator in degrees, and that is 7.7 feet. So I'm going to continue that line down and just think logically, hey, does that make sense? Yeah, that could easily be about 8 feet. And when I carry those lines down, I notice that, hey, that's the same position as I, and this other one here is the same position as J. So I think I've kind of already found half of my circle. I know that this 18 seconds over here at J is also 20.2 feet. And I know this 16 seconds down here at position I is also 7.7 feet. Using that, I want you guys to fill in the rest of the wheel. Fill in D, E, F, G, and H. And just like we did with sine, I want you to graph that on number 4. This time, we truly are starting at a different point. If I look at position A, we're no longer starting at a height of 30 feet off the ground. We're starting at that 25 feet away from the center. So when we go to graph that, we're starting at 25. Well, 20 seconds later, we're right back where we started. And our second rotation of the wheel, 40 seconds, we're right back where we started. You fill in the points in between. So here is task 4.8. Like I said, review this once more if you need to go back over it. Come to office hours with any questions you've got. I would love to see an uploaded graph of your sine from task 4.6 and an uploaded graph of your cosine right here, number 4 from 4.8. See you guys in office hours.